Hey, once again looking at the isometries that are reflections. Remember, an isometry preserves congruence, it preserves size and shape. We also can call these congruence transformations or rigid transformations. All we're doing is changing the position of our shape. Okay, so here it says reflect ABC across the y-axis. There's our y-axis. If you remember, to perform a reflection, we find the distance perpendicular to our line of reflection. This is 7 units to get to our line of reflection, so we're going to go 7 units away, and that's going to be our new point, still perpendicular to our line of reflection. So that would be A prime. B was 2 units away, so we go 2 units on the other direction. That would be B prime. And C is 7 units away, so we go 7 units away. I've been doing dashed lines, so I'm going to keep that going. And there is C prime right there. If we connect these, we get our reflected triangle A prime, B prime, C prime. We're going to find these. We're going to see what's going on here. A was that point -7, 6. A prime was 7, 6. Notice how similar those are. B, from our pre-image, was the point -2, 3. B prime is the point 2, 3. Finally, C is the point -7, 1. C prime is the point 7, 1. Notice when we reflect across the y-axis, that's what we were doing, the x-coordinate changes sign. That's the only thing that happened. Our x-coordinates changed their sign. The y-coordinates stayed exactly the same. So to perform a reflection across the y-axis, all we have to do is change the sign of the x-coordinate. Pretty crazy stuff there. Here it says reflect the rectangle STUV across the line y equals 4. Okay, we can do it. V, 2 units away. We're counting by 2's here. 2 units to the line of reflection, 2 units away. There's V prime. S, 4 units to the line of reflection, 4 units away. There's S prime T, 4 units to get to the line of, 4 units to get, 4 units to get away. U, 2 units to the line of reflection, 2 units away. There would be our reflected figure there. Okay. Now, it says, notice when a point is reflected across a horizontal line, its x-coordinate doesn't change. When a point is reflected across a vertical line, its y-coordinate didn't change. So we solved that, we noticed that. To find the reflection of a point across any line in the coordinate plane, we can draw a perpendicular line from the point to the line of reflection. We can still use the fact that it's going to be the perpendicular distance. Here, we want to reflect this quadrilateral across the line y equals x. We can notice the distance from the point M to the line of reflection, and we go that same distance away. L to the line of reflection, L away. We can keep doing this for all of them, but this is what I wanted to tell you. Have a little heart-to-heart here. If we want to reflect something across the line of reflection of y equals x, to reflect across y equals x, we exchange the x's and y's. What do I mean by that? We'll take a look here at my mapping notation. xy becomes yx. To reflect across y equals x, we exchange the x's and the y's. I want you to know that. I want you to know that. So M, notice the coordinates for M is 0, 1, so that means M prime is going to be at 1, 0. L is at 3, 5, so that means L prime is going to be at 5, 3. K is at 0, 8. That means that K prime is going to be at 8, 0. Finally, J is at -3, 5, so that means that J prime is going to be at 5, -3. We connect those bad boys to get our reflected figure. To reflect across y equals x, exchange the x's and the y's. Finally here, Marina is creating a work of art using part of a photograph and its reflection in a coordinate plane. The corners of the photograph fragment are located at -3, 2, at 2, 8, and at 10, 2. We want to reflect this fragment across the line y equals 2. We want to reflect this across the line y equals 2. Well, these 2 points on the line are not going to move. They have a distance of 0 to get to the line of reflection, so 0 away means they do not move. It's just this point right here with a distance of 1, 2, 3, 4, 5, 6 to get to the line of reflection, so we go 6 away. 1, 2, 3, 4, 5, 6. And so our reflected diagram looks like this. There we go. Reflections. Don't be scared, but remember that idea about when we reflect across horizontal, vertical lines. If we reflect across horizontal lines, the x's are not going to change. If we reflect across vertical lines, the y coordinates are not going to change. And when we reflect across y equals x, we exchange the x's and the y's.